everybody. In this video we're going to be talking about Kirchhoff's laws. So there are two: Kirchhoff's current law, which you just call KCL, and that's you take the sum of all currents at any node and it's zero, and I'll show that in a minute. Then there's Kirchhoff's voltage law, which you just say KVL, and that's you add up all the voltages around any path in a circuit and that's zero. Okay, so for example, like here's a node. That's where two circuit elements connect to each other. So that means if I take the current here and the current here and add them together, it's zero. It means however much current goes into the node has got to be leaving the node. It's basically conservation of charge. But maybe that's not so exciting. But a node like this means, like, say there's current coming in here, whatever goes in there, like say it's 3 amps, then it's got to be 2 amps going that way, 1 amp going this way, right? You add them all up, it's zero. Kirchhoff's voltage law, KVL, is you add up the voltages as you go around like a path like this, and they got to add up to zero, right? Like if you gain 50 volts and then you lose 30 volts, then you got to lose another 20 volts here, right? Because you're coming back here to the same point. You can also go around this path. In this particular example, notice that, right, this and this, right, they're the same voltage because they're connected to the same nodes. But then it's like saying if I go, like this is plus 10 volts, then this has got to be negative 10 volts, right? If I come back here, they got to be the same voltage. Or you can go around this way. Okay, let's use Kirchhoff's laws with Ohm's law to solve for everything. Let's solve for everything. Meaning the voltage. Let me just label these. I'll call this, let's call this R1. And I'll call this R2 and R3. And then let's make voltage V1 this way. And again, you can choose the direction however you want. There's no wrong choice. Right? So we could have picked voltage going this way. That's totally fine. There's no wrong choice. Okay, and then for this one, how about if I pick voltage this way, and then for this one, we know that if I call this something else, we know that these are equal, right? So maybe I won't pretend like I don't know that. They're the same voltage. And then for current, how about I go this way, and this way. Okay, let's practice using Ohm's law. So for this one, notice how voltage is positive going toward the right, current is positive going toward the right, so that means V equals positive IR. Same here, I chose to label it so the voltage is positive going down, the current is positive going down. So the way I labeled it, positive IR. And then here, the way I labeled voltage going down, current going down, so V is IR, right? Just because of the way I labeled things. Let's practice KCL. Okay, so let's call this I'll call this node A. So node A looks like, see how this current is going in, this current is going down, and then this current, right, like this, is going this way. It's going this way, this way. Okay, so for KCL, you decide if going into the node is positive or leaving the node is positive. Up to you, it doesn't matter. Okay, so let's say going out of the node is positive. So then that means this is negative, right? So I add them all up. Negative I1 plus I2 plus I3 equals 0. So real quick, if I chose the other way, like if I say going into the node is positive, that would mean I1 is positive, I2 is negative, and I3 is negative. Look at this algebraically. Same thing, right? So that's why it doesn't matter. Okay, so we got 4 equations for 5 unknowns. It's pretty good. We just need one more equation. If we try node, I'll call this node B. Node B looks like there's current. See this one like this? Right, this is I1. Node B. I1. And I2 is going downwards. And then I3 looks like this, right? So for node B, let's say leaving the node is positive. So then I1 minus I2 minus I3 equals 0. Okay, the problem is, look at these two equations. They're dependent, right? So I don't have 5 independent equations. I only have 4 independent equations. So this didn't help me. Right? So that didn't help. I still need one more equation. Let's try KVL, Kirchhoff's voltage law now. Okay, so Kirchhoff's voltage law is you go around like this, right? So this one will not help us, right? Because if we go minus V2 plus V2 equals 0, right? We knew that already. So how about we go over here? I'll call this path C. And you can choose clockwise, counterclockwise. Doesn't matter. Okay, so I just happen to choose clockwise. It doesn't, you can choose counterclockwise, totally fine. Okay, so let's go this way. Is that positive or negative? That's voltage rise, right? Because positive is drop. So this is negative 50, right? Negative 50. Going this way. Okay, now we're going this way. So look, this way, right? That's positive V1. Going this way. This now going down this way. So that's positive V2. Equals 0. That's KVL. So that's an independent equation. Now we have 5 equations. 5 independent equations. For 5 unknowns. Okay, so give this a try. We'll do some more examples online. I'll see you on the next video.